Hello everyone, welcome back to Irfan CFPS YouTube channel. In today's session, we are going to discuss about fire alarm system basics. Basically, we are going to cover three topics in our session. First topic will be related to the basic components of each fire alarm system, and second topic will be type of fire alarm signals, and the third topic will be the type of circuits which are going to be used in fire alarm system. If this is the first time you are visiting my channel, make sure to hit the subscription button below and also click the notification icon to get the updates. So before we jump into our today's topic, we are going to have a look about the components of the fire alarm system once again, which has been discussed in our earlier class. So fire alarm system typically consists of a control panel, smoke or heat detectors, manual pull station and horn strobes. Here you can see the figures. This is the control panel, detectors, manual pull station, horn with strobe. When a detector senses smoke or heat, it sends a signal to the control panel which activates the alarms or horn strobes. If you want to know about the function of these devices and the control panel, you need to watch my earlier video on overview of fire alarm system as per NFPA 72. So let us discuss the basic components of fire alarm system. So basically we have few components. We will have a system control unit or fire alarm control panel which can be operated by a primary or main power supply. This is the primary source of power supply, and in case of power failure we need to have a backup, so we'll use a secondary or standby power supply. This should be operated within 30 seconds when the primary power supply is not capable of providing the minimum voltage required for proper system operation. So basically these three components are related to the fire alarm control panel, and here you can find IDC, which is called as initiating device circuits, or SLC, signaling line circuits. Basically these circuits are connected to the smoke detectors, manual fire alarm boxes and also the sprinkler flow or alarm initiating devices. And you have one more component called NAC, notification appliance circuits. These are connected to the horn strobes or horns, strobes or bells or speakers. And also this fire alarm control unit can also be connected to the remote supervising stations. So basically these are all the components which can be used in each fire alarm system. In this particular slide, I am going to show you the schematic diagram of fire alarm system. Basically, we will have a fire alarm control unit. In the initial stage, the system will be under normal condition without any troubles or alarms. Without fire alarm control unit, we cannot imagine the fire alarm system. And there are two types of fire alarm control panels. One is conventional, the other is addressable. So if you want to know the difference of conventional and addressable type fire alarm panel, you need to watch my earlier video on overview of fire alarm system per NFPA 72. Now coming back to the schematic diagram, the primary power supply is connected to the fire alarm control unit, and secondary power supply or standby batteries will also be installed in the fire alarm control panel, or they can be installed near the fire alarm control panel. So the initiating devices like smoke detector, heat detector, manual pull stations and flow switches will be connected to the fire alarm control panel. We'll discuss about this alarm, trouble and supervisory signals in our next slide. And these devices which is connected to the fire alarm control unit. So this wiring will be called as initiating device circuit, For conventional devices, we call as IDC. If we are using addressable devices, then this terminology will become signaling line circuits. And if you want to know the status of the fire pumps, then we need to install monitor modules in order to get the signal or give the indication to the fire alarm panel. And also, if we have kitchen hood fire suppression system, we will use some modules. Those will also be connected to the fire alarm control panel. Whenever the fire alarm control unit receives the signal from the initiating devices or supervisory devices, then it will activate the horn strobes. These horn strobes can be called as notification devices, and this circuit is called as notification appliance circuit. Apart from this, we have emergency control functions like the wiring can be connected to the elevators. In case of fire, this fire alarm control panel will close the elevator options, and also this fire alarm panel can be connected to the remote supervising station, so that whenever a fire occurs, this panel will give a signal to the or communication will be given to the supervising station. So let us look at the types of fire alarm signals. As I already told you, this fire alarm control panel or any fire alarm control panel basically have three signals like alarm signal, trouble signal, and supervisory signal. Alarm signal basically is a warning of fire danger that requires immediate action. It means whenever there is a fire inside the building, then the initiating devices give alarm signal to the control panel. If you want to explain in some other direction, we can say, for example, a smoke detector will send a signal to this fire alarm control unit that there is a presence of smoke inside the particular building, which would initiate the notification devices so that the occupants can evacuate from the building. The second one or the second signal will be trouble signal. This signal indicates a fault in a monitored circuit or component of the fire alarm system or the disarrangement of the primary or secondary power supply. It means basically this trouble signal occurs when there is an issue with the wiring or there is a fault within the fire alarm system. And the third signal will be supervisory signal. So basically this signal indicates that the action is needed in connection with the operation of other fire protection systems that are being monitored by the fire alarm system. In short, if I want to explain about supervisory signal, for example, in a particular building, we have a sprinkler system installed and the flow switches and the tamper switches are installed on the valves and the piping network of the sprinkler system. If the valves are being closed, then the signal will be given to the fire alarm control unit as supervisory trouble. Then we can go to that particular valve and open that particular valve, because basically sprinkler valves or the sprinkler piping valves shall be in normally open position. If these valves are closed, we will get a supervisory signal on the control panel. Let us go through the type of circuits used in the fire alarm system. There are three basic types of circuits. Number one, initiating device circuits or IDC. We have signaling line circuits. As I already told you, this terminology of SLC will be used for addressable systems and IDC terminology will be used in conventional systems. And the third circuit is notification appliance circuits. These circuits will be connected to the horn strobes or speakers. So let us have a look at initiating device circuits. We already discussed about the initiating devices. Here you can see the fire alarm control unit is connected to the initiating device circuits, and this will be closed by using a resistor. Now we are going to discuss about this in our next slide, but before that we'll have a look about certain points of initiating device circuits. This circuit's function is to report the status of a protected space or the existence of fire in a particular building. As I already told you, if a fire occurs in a particular building, these devices will sense and give signal to the fire alarm control unit. And the second point will be these initiating devices circuits connect conventional fire alarm and supervising initiating devices to the fire alarm control panel, which has been discussed in our earlier slide. The signal from an initiating device can create an alarm condition or a supervisory condition. Let us thoroughly go through the initiating device circuit. See, basically, for example, you have a particular building and it is of one floor. You have a detector installed, and this detector is connected from the fire alarm control panel. So for this we will mention like SD smoke detector, and here for example you have a door, and we are going to install manual pull station. This also be connected to the smoke detector circuit, which is called as IDC initiating device circuit, and we have a horn strobe installed on the building. Here I am showing a tentative height of this horn strobes, manual pull station and smoke detectors. Basically we need to follow NFPA 72 in order to consider the height for these particular devices. So now coming back to the initiating device circuit, we have a fire alarm control unit. If a particular fire occurs in this particular building, then this smoke detector will senses smoke and give signal to the fire alarm control panel. From this fire alarm control panel, one more line is going to the horn strobes. So automatically once this fire alarm control panel receives a signal from smoke detector, it will activate the horn strobe. So this is the concept. Or else if there is a fire occur in this particular building, then any person looks at this fire, he can activate the horn strobes by pulling the manual call point, or we can call as manual pull station. There is a lever here. There are several models, but basically there is a lever in manual pull station. The person can pull the lever so that it will give signal to the fire alarm control panel. Thereby it will activate the horn strobes. Here you can see the circuit diagram. This for example you consider as smoke detector, this like heat detector, and this like manual pull station. Basically the wiring will be in this particular way. The wire will come and go, or it will go out from here itself, you can see, and it will be connected to the resistor and will go back to the fire alarm control unit. Resistor will draw the current, and whenever this is called as normal condition, if there is fire occurs or if there is any alarm condition, then this will short. As you can see here, this will short. For example, this device shorts, so the current will increase here. So the panel gets more current, which thereby connected to the horn strobe will activate this particular horn strobe. In order you to understand, I will show you one example. For example, we know V is equal to I into R, current into resistance is equal to voltage. Now for example, we consider like in normal condition this resistance is of 6000 ohms. Okay, please ignore my handwriting, just try to concentrate on the subject. Apologies because my handwriting is not that much good. Here for example, we have 6000 is the resistance in ohms, and we have 24 VDC voltage. Basically this will be 24 VDC, and we need to calculate the I in normal condition. So the current will be in normal condition 24 by 6000. We are going to get about 0.004. Okay, ohms. I'm sorry, this will be amperes because we are going to measure the current, so this will be ampere. Now if there is any alarm condition or supervisory condition, the current will increase. How? See here, for example, now V is equal to IR is the same formula which we are going to use. Basically now we don't have R is equal to 6000. Since it is short here, the current will flow from this device. Basically these devices have less current or less resistance, which is about, maybe for example we consider as 0.02, or we consider like 0.2. for example, this is only an example just to show you how the current increases if there is a short in the network. So 0.2 is equal to, here we will have 24 VDC current, and I will be after short or in alarm condition 24 by 0.2, which will comes about, I believe, about more than 100 amps, about 120 amps. See the difference between the current. In normal condition the current is less, and in short condition or in alarm condition the current flows more. So whenever the current is more, the fire alarm control panel will activate or initiate the horn strobes. I hope you understand the initiating device circuit concept. This is a lengthy one, but I hope it is clear for you now. So let us have a look at the SLC and NAC circuits, signaling line circuit and notification appliance circuits. Signaling line circuits looks like this, and notification appliance circuits will look in this way. And SLC is used to define circuits over which two-way data communication take place. Basically this SLC terminology will be used for addressable systems. And notification appliance circuits or NAC connect notification appliances like horn strobes to the fire alarm control panel. I hope you understand the basics of fire alarm system. In next class we are going to discuss about schematic diagram of fire alarm system by using the device symbols. Basically this schematic diagram illustrates the interconnection of various components within the fire alarm systems. This schematic diagram serves as a blueprint for installation, maintenance and troubleshooting. If you like my videos, please subscribe to my channel and make sure to hit the subscription button below and click the notification icon to get more informative content on firefighting and fire alarm systems. Thank you so much. Bye.